ठीक है। तो नाउ इंडक्शन मोटर का एक पार्ट है स्टेटर। Understand? Stator. So stator is responsible to provide a magnetic field. Understand? Now, the perfect induction motor is three-phase induction motor. Three-phase. Three-phase. Understand why? Why? We have, when we excite this, everything, winding. Now, three-phase winding. Three-phase winding. That may be connected in delta or star for your requirement. Maybe for starting purposes, we use a delta connection of the stator, and for a running condition, we just convert these connection to star. So that is in another, starting method of induction motor, and we just put some box that is in star delta converter. That duty is done by that box, that device, which is called star delta converter. Understand? So now look at over here. One part is stator. Inside the stator we have an windings. That winding we consider as in three-phase windings. Three-phase. And when we energize these windings by a three-phase supply, what will happen? What will happen inside this stator? Rotating magnetic field. The magnetic field which is produced by this three-phase supply, the characteristics of this magnetic field is like in rotating magnetic field. Understand my point? Rotating magnetic field. Rotating magnetic field. So the rotating magnetic field is like this. First, it is in rotating inside the stator, and we will prove by mathematically. We will prove that three-phase supply generate a rotating magnetic field, and we will prove by a mathematical equation or mathematical proof. Understand my point? But now today we will study about the basic principle of operation of induction motor. Understand my point? Now, are you agreeing?
Yes.
When we energize this stator of winding by a three-phase supply, the magnetic field produced by these three-phase supply is look like a rotating magnetic field. Understand my point? Now the rotor construction in induction motor is very different from DC motor. Very different. Understand? So the rotor, I got a blue color marker position. So, it is in rotor. What is rotor? Rotor of the induction motor. Understand my point? Now we will look inside this rotor. We will look inside this rotor. So inside this rotor we have a thick copper bars that is in conductors, conductors, but in shape these are the thick wires. Why? Because the heavy current will flow through these bars. Understand? Heavy current flow in bars. That is why we put a thick copper bars. इसको copper bars कहते हैं. Books में आप पढ़ेंगे ना, वहाँ पे कंडक्टर नहीं मिलेगा, आपको bars मिलेंगे. Thick copper bars. So how it look like? It look like this, you know. ये बार है, understand? Thick bar. So इसको हम क्या करते हैं, यहाँ पे शार्ट करते हैं. Understand? So another bar like this. Understand? Short circuited copper bars. And by the way, this type of rotor is called squirrel cage rotor. Squirrel cage rotor. इसमें आप लोगों को, अगर आप जब रोटर को देखेंगे तो आपको बार्स नजर नहीं आएंगे. Understand my point? Ik zou zeggen, rotor funcționează proste, dar late, dar o ală de induction motor ală. Dacă tu nu mă vei, tu te mă poți roade roada. Ai că DC वाला roada, induction motor वाला roada. Induction motor eu dunde eu scop de ala ala. ठीक शो? There are more explain cum pada takile mai. So now look at over here. It's a very small rotor of induction motor. खबर है ना ऐसा. So, it is an induction motor rotor, but as in construction, it is look like a single phase induction motor. Understand? So look at over here. The bars are like in these lines, you know. And these lines are skewed, not very straight, you know. It is not very straight. Look at over here. Not very straight, skewed. Why? It is a question for you. Why it is skewed? Why it is not, you know, straight? Small questions. Understand my point. But for you guys, that in these lines there are copper bars inside this. Understand? वायर से कोई कनेक्शन इसमें नहीं होता है. इसके अंदर जो है ना कॉपर बार्स होते हैं, वो शॉर्ट सर्किटेड होते हैं, and then it is packed with that. Understand my point? Now what will happen when I lie this rotor and this stator, you know, like this. Understand? So the flux is rotating like this, and the flux cut these bars somehow maybe less than 90 or something like that, but very near 90. Understand my point? Understand my point? Yes. Now look at over here. When the rotating magnetic flux, when the rotor is lying in this stator, the rotating magnetic flux will cut these bars. Because this rotor is stationary, usually it is in stationary position. And the speed of this rotating magnetic field is like ns is equal to 120 F for frequency divided by B for pole. Understand? F divided by P, P for pole, F for frequency. So it is a It is in synchronous speed of rotating magnetic field. The rotating magnetic field will rotate with this much speed. For example, we have F frequency is 50 Hertz, and for example P for two poles, minimum 2 poles. Understand my point? So 120 multiplied by 50 divided by 2. So how much is this one?
750.
How much is this one?
750. Yeah.
3,000 RPM. That is revolution per minute. 3,000 revolutions per minute. Understand? The small numbers, And when, look at over here, when you put 4 pole, it will be half. That will be like in 1,500 revolutions. Understand my point? Now, when I lie this rotor inside this stator, there is a rotating magnetic field, and with this bars are cut by this rotating magnetic field, like very near to 90 degrees. Rotating magnetic field. And that rotating magnetic field, the speed of that rotating magnetic field is how much? If the poles are 2, the rotating magnetic field speed will be 3,000 revolutions per minute. Understand my point? Now, what will happen? When these bars are cut by the magnetic field, what will happen to these bars? The EMF will be induced in these bars according to the Faraday's law of electromagnetic induction. What Faraday says? Faraday says, whenever the conductors are cut by a magnetic field, there will be EMF induced in that conductor. So, the condition is fulfilled over here for a Faraday's law of induction. There is a conductor, and there is a magnetic field which is cut these conductors. The EMF will be induced in that conductor. Is it true?
Yes.
True? Are you agree with this? So now, whenever the EMF is induced in this conductor or these bars, what will happen to these bars? Because these bars are closed short circuit, and EMF is induced in that conductor, there will be a heavy current flowing through these bars. Heavy current. Current I. Current I. Current I. Understand my point? Initially, you just, clear your concept that initially this rotor was at rest, 0. And this rotating magnetic field was 3,000. So how much, with how much speed these conductors are cut by this rotating magnetic field? 3,000. Heavy EMF will be induced in these bars. Understand? Current will be flowing these bars because these bars are short circuited. Now, whenever flux cut these bars, EMF is induced in these bars, current is flowing in these bars. Now, another condition is fulfilled over here. Now, these bars are current carrying conductors. Understand my current carrying conductor. Are they a current carrying conductors? No. Is it true? Current flowing through these conductors, and where it is lie? Or where? Straight. So these are the current carrying conductor in a magnetic field. Because the rotating magnetic field, it is a magnetic field. You know, that is rotating magnetic field or stationary or non-rotating magnetic field. Doesn't matter. When you lie a current carrying conductor in a magnetic field, there will be a force in that conductor. Is it true? So on each conductor or each bar, there will be a force like this, you know. When there is a force on each section of this rotor, what will happen? It will be rotated. It will be rotated like this. Understand my point? Now look at over here. Initially, this rotor was at rest. Maximum EMF was induced in these conductors. Maximum current was flow through these bars, and maximum force was experienced by these bars. And in result, this rotor starts rotating in the direction of rotating magnetic field. Tikso yo gare da saraman de volar de or sarabaso roman. Mas के वोलारो tikso yo स्पीड से देखा लाड़ो ये चला गया और दोबारा से जब ये चला गया तो ये इसने भी स्टार्ट किया. इसने स्टार्ट ले लिया. अब फॉर एग्जांपल इसकी मुझे एक स्पीड बताए कि इसकी स्पीड रेस्ट से इसने अपनी स्पीड डेवलप की है somehow like 500. फॉर एग्जांपल 0 से ये स्टार्ट करेगा तो कोई भी आप मुझे स्पीड इस तरह दे कि फॉर एग्जांपल इसकी इतनी स्पीड हो इनिशियली इतनी है 0 से कितनी 40 50 कर लेते हैं 50 रिवोल्यूशन पर मिनट कितना 50 rpm. Understand? 50 rpm 50 revolution per minute. Now look at over here. The speed of rotating magnetic field was 3000. Never change with this rotor or this rotor rotation. It is constant. That is why it is called NS, synchronous speed. Synchronous speed never changes. So the speed of rotating magnetic field never changes. This speed was, we assume initially that the speed of this rotor from rest, when it is, start rotating, it is reached to 50 revolutions per minute. Understand my point? Now look at over here. Rotor is rotating with a 50 revolution per minute. And rotating magnetic field is rotating with 3000 revolutions per minute. In the same direction. What will be the relative speed of these two? Rotating magnetic field and rotor speed. What will be the relative speed? Do you know the relative speed? When two cars are, running on a highway with a speed of, one car is in the speed of 100 km per hour, on another one is on 50 km per hour. So what will be the relative speed of these two cars? 50. And one car is 100, another one is 70 km per hour. Relative speed will be 30. So now, speed of rotating magnetic field is 3000. Speed of rotor is now initially 50 revolutions per minute. So the relative speed of these two in same direction, So what will be the relative speed? 2950 revolutions per minute. Now the flux, rotating magnetic flux, is cutting these bars with a speed of 2950 revolution per minute, which is less than 3000. Which is less than 3000. But still, there is an EMF induced in these conductors, current flowing, and the speed is increasing. Speed is increasing, you know. So, for example, it is reached to 500. 52, for example, over here. 50, 500 revolution per minute. So now, this is a rotating magnetic field. Speed of this rotating magnetic field is 3000. Now the rotor speed is reached to 500. Now the relative speed, how much is the relative speed? How much? 25. Now the bars are cut by a rotating magnetic field with a speed of 2500 revolution per minute. Understand? It is less than 3000, you know. The EMF induced in these conductors are less as compared to 3000 revolution per minute of rotating magnetic field speed. Understand my point? Understand my point? Now, still we have a current through these bars, still we have a force on these conductors. Understand? And still it will be increasing in speed. Understand? For example, 1000. Now the bars are cut by a rotating magnetic field is 2000 revolution per minute. Still we have an EMF induced in these conductors. Still we have a current through these conductors or these bars. Still we have a force on these bars, and still it will increase its speed. Already it is rotating at 1000, but there is force inside to rotate more revolution per minute, you know, speed up. ये साढ़े रवान दे तेज रवान दे, हाँ तब तो से वो प्रोडक्शन सपेड़ा पर नूर कम तेज की कहना गाड़ी रवान पड़े दे 100 किलोमीटर पर आवर उसी मामूली शांत वाले एक्सीलेटर वाले करना बंदे वो नूर की वो ये रनिंग कंडीशन के it's the same example is over here. Whenever we have a current through these conductors, there will be a force on this rotor, and the speed will be increased greatly. Understand my point? But when the speed of this rotor is increasing, the force on these conductors will be decreasing, you know. Why? Because when the speed of rotor is increasing, the cutting of these bars by a rotating magnetic field is decreasing. The relative speed is decreasing. Understand? Until and unless when this rotor speed is reached to 3000 RPM. It is a very turning point in induction motor. When the rotor speed is equal to the rotating magnetic field speed. Understand my point? The relative speed is 0 now. The relative speed is 0 now. Both are rotating with the same speed. Understand? So when both rotating magnetic field and rotor speed is same, there will be some EMF induced in these conductors. When both are rotating at the same speed. When one car is, running at 100 km per hour, another one is also, speed up to 100 km per hour. Both are in parallel. So what will be the relative speed? 0. Both the passengers are seeing to another car passengers way, calm and cool, they will look like it's stationary for you. Understand? So same example is over here. When rotor is rotating at a speed of 3000, rotating magnetic field speed is 3000, both are in same speed, same direction. The relative speed is 0. There will be no cutting of flux by these conductors or these bars. Am I right? Am I right? There will be no EMF induced in these bars. And both are at same speed. Relative speed is 0. देख 3000 माने कावी की आम 3000 मानता है 10 पेड़ जुदा से वहाँ दशा को मख मान अब आगे और सर पर मख को आगे स्पीड से बूझी जी कम स्पीड से जमा लास्ट का मान दे आगे तब सपेड़ में महसूस understand because both speeds are same relative speeds यो दारा वाला के बच्चे लगम दास को टच को आते है ना मुंगम दास को ऊपर स्टोर करता तो जब दोनों जो है ना सेम स्पीड पे जा रहे हैं ईएमएफ इंड्यूस नहीं होगा इसमें ईएमएफ इंड्यूस नहीं होगा ना when there is no EMF induced in these bars due to a speed of this rotor because this rotor speed and rotating magnetic field speed is same no EMF induced in these bars no current will be flow in these bars and when there is no current through these bars there will be no force on these conductors or these bars. Understand my point? There will be no force because force lie on a conductor when there is current flowing through these conductors. But now the current is 0. Why? EMF induced is 0. Current is 0. Force is 0. What will happen? Rotor will be slowed down. Just accelerator na pada rin gaga ko para sa atrás. Ro so diga. Upon 100 kaya rawan na wala na makisi. Understand my point? When it is slowed down, again there is a room for a relative speed. This rotating magnetic field speed is constant. Rotor is now slowed down because of no current through these bars. And then it will create relative speed between these two. For example, ये 3000 से 2900 revolution per minute तक ये slow down. अब relative speed कितना है 100 revolution per minute. Again, EMF will be induced in these conductors. Current will be flowing in these conductors, these loops. And when there is current, there will be a force. When there is a force, it will be shoot down or just speed up. Understand my point? Now, this scenario was on no load. There is no load to these shocks. Freedom. So keep in mind that in induction motor, a rotor cannot reach to the speed of rotating magnetic field. Keep in mind. Why? Because whenever rotor reaches to the speed of rotating magnetic field, there will be no EMF induced to the rotor bars. And when there is no EMF induced to the rotor bars, there will be no current flowing to these bars. And when there is no current through these bars, there will be no force on these bars. And when there is no force, there will be no further increase of speed of this rotor. Understand? The rotor will be slowed down. And again, when it is slowed down, rotating magnetic fields will never slow down. Again, sum of induced EMF. Understand my point? Now look at over here. When we put a load to this shaft, can you say that this rotor now can reach to the speed of rotating magnetic field?
No.
It is very similar. I just fix the speed of a car on a motorway, that is in 100 kilometers per hour. I just put fixed speed. ठीक so? Fixed speed. That is in cruise control, 100 kilometers per hour, same speed. And there is no passenger in this car. ठीक so the speed will be 100 kilometers per hour. And when I put a 3 heavyweight passenger to this car, what will be happen to the speed? Slow down. Or when you like to travel on 100 kilometer speed, you will just push your accelerator more than the previous. No. Normal accelerator was gauge 100 kg. But our accelerator was 100. But our accelerator was 100. Why? Because I just put load on this shock. So it is very good to know that these kind of electrical or AC machines are used in electric vehicles. Tesla, all of kind of the electric vehicle, heavy electric vehicle, using Prius, better Prius is also using 3-phase induction motor. And why they are using a 3-phase induction motor in electric vehicles, there is very a big advantage for them. A big advantage for them. Understand my point? Now, what is that big advantage for them? That is a speed of a rotor. When you drive your car or a hybrid car on a speed of 60 kilometers per hour, anybody did drive the electric car or hybrid car? Prius. Kalau macam boleh deh. Cara mau kita ni kena jelasin macam ni.
Sono speed ci vuole.
Sono speed ci vuole. Sono 60 kilometer per hour. Speed na. Ci vuole che segni. Ya, kereta nauri. Dia petrol. 60 por hora por dia. Up to 60 km per hour, the hybrid cars are running on batteries. And when we push the accelerator more, we need more speed. Push it. More speed, the speed will be increased from 60. And the car will be converted to the petrol engine. Now engine can, accelerate this car up to 100 km, 150 km per hour. But why on a 60 km per hour the car is running on batteries? Because they just calculate that on a 60 km per hour the speed of the rotor is less than the rotating magnetic field, or very near to the speed of rotating magnetic field. Near to, or you can say that, I can say that on a 60 km per hour, the speed of the rotor and the speed of rotating magnetic field is same. And whenever the speed of rotating magnetic field speed and a rotor speed is same, there will be no force. I just explained it on this rotor. But I need more speed. I just push the accelerator. Now the axle is, converted to the engine, because engine can move these tires very fast. This shaft will be also coupled to the tires. This shaft will be also rotating more than a 60 km per hour. Understand? So now what will happen? This rotor is now rotating inside this stator at the speed of more than rotating magnetic field speed. Which way? When it was, not loaded or not, free running, this rotor cannot reach to this speed of rotating magnetic field. Why? Slow down. Because when it is reached to this speed, it is slow down. I just explained the process why it is slow down. Understand? But now it is coupled to the car engine. Car engine, moving these tires more than 60 km per hour. Now this rotor speed is more than the rotating magnetic field speed. What will happen? Now, up to the, or less than the 3000 revolution per minute speed of the rotor, it is act like a motor. It is act like a motor. On a 3000 revolution per minute, it is act like nothing. More than the 3000 revolution per minute, it is act like a generator. It is called induction generator. Now, when I exceed the speed of this 60 km per hour, this motor is act like a generator. And when we see that, when our speed is more than the 60 km per hour, our battery can discharge. The load of the car is on an engine, but batteries are charging. Why? Where is it? This power comes from this induction motor. That is जरूरी point है, बहुत जरूरी point है. हाइब्रिड गाड़ी का मैंने आप लोगों को बता दिया कि कैसे काम करता है. कलम चलो देता 64 आला बैठे हैं मैंने से.
Yes, sir.
चंदूर तालुका क्या का इंजन फिजिकल आला इंजन का कन्वर्ट करना और तब तक वो रहेगा पावर से कम दे बैटरी आने की चार्ज की वाले जिद्दार जनरेटर शीया देने में जनरेटर जोश इससे जनरेटर बन जाता है. और जब जनरेटर बन जाते तो वो पावर का मैंने निकालना क्या है, वो पावर को मैं बैटरी चार्ज करता हूँ. फिर जब थोड़ा सा चार्ज हो जाए चलता है फिर जो है ना वो मतलब कभी बैटरी कभी जो है ना उसके डिपेंड ऑन योर रिक्वायरमेंट. So that was an induction motor. Principle of operation of induction motor. A minimum requirement for a rotating magnetic field, minimum requirement is 3 phase. We can generate a rotating magnetic field very easily to excite this stator by a 3-phase supply. But we have a single phase induction motor like fans, like water pumps. Single phase motors are very frequently we use in domestic, so that is another topic, single phase induction motor, how it is work when there is no production of rotating magnetic field by a single phase, then how it is work. So we just put some extra winding, extra techniques to generate a rotating magnetic field. That is the topic of future lectures. Understand that? Or upcoming lectures. Understand my point? But instantly your fan capacitor is burned out. What will happen to the fan? Never. That's the start. You will just push this fan to some speed, then it will be that's rotator. But never, speed of the fan reach to very comfortable speed, Until and unless you put a capacitor inside this fan, the speed will be increasing. And the value of capacitors, when you just increasing that value of capacitors, the speed is increasing more for a single phase. Take sure? Naga biya munga makikla. So we ostas ko de three phase ko shoi. Tida sang da ukar kai uzi ko banana na makuna. Da formula sho da synchronous speed. Yo chekam de global formula da NR rotor speed. How the rotor speed is 120 F divided by T. Same formula. What's the perfect? Again, we slip. So we slip. The difference between rotating magnetic field speed and rotor speed. The difference between rotating magnetic field speed and rotor speed is called slip. Initially, slip is very, when the rotor is at rest, slip is 100%. And when the rotor speed is equal to the rotating magnetic field speed, the slip is 0. And in these 2 points, 100% slip and 0% slip. Understand? There is a slip, between these 2 points. Depend upon the speed of the rotor. Over here, when the slip is 100%, rotor speed or rotor at rest. Rotor at rest. And at 0% slip, rotor at rotating magnetic field speed. Push by take show. No load. Now look at what there. At no load. There, how much slip will be at no load? Near to no load. The slip kitna hoga when it is running in running condition. Somewhere like over here. जीरो स्लिप पे इसलिए जीरो स्लिप तब हो जाता है जब इसका स्पीड जो है रोटेटिंग मैग्नेटिक फील्ड को रीच करे. तो रीच के लिए तो वो छोड़ता ही नहीं है. वो तो जब whenever the rotor speed is reached to the rotating magnetic field speed, everything is stopped inside this rotor. No induction, no induced EMF, no current flowing, no force. Nothing. It is automatically slowed. Understand? So no load के लिए. और जब आप इस पे लोड लगाते हैं, when you put a load on the shaft of this rotor, the speed of the rotor will be decreasing with the load. Decrease की कब है decrease की और शायद ये सामान इतना नहीं बोले. नुको decrease की बताना. When the speed of the rotor is decreasing, slip is increasing, somehow like this. Depend upon the load. It is in small load, or here, heavy load. These depend upon the load which slip you will have. उस कोई से what is slip? What is slip? Google को एक अच्छा अच्छा सारा नेट में slip formula से that is ns minus nr divided by ns into 100. मात्र कहिए तो तास पहले लगा तो बहुत ठीक है लाते हैं ns minus nr divided by ns into 100. ठीक है इस फार्मूले पे न्यूमेरिकल आएंगे भाई, ये मैंने बता दिया। इंडक्शन मोटर के 2-3 फार्मूले हैं, ज्यादा है ही, बस उसी पे न्यूमेरिकल हम करते हैं। ठीक है, द three formula is the first one is the n s और n r वाला फार्मूला सेम, स्लिप का फार्मूला थोड़ा सा डिफरेंट, बट इट इज वेरी सिमिलर टू द रेगुलेशन फार्मूला। व्हाट इज रेगुलेशन फार्मूला बताते रहते हैं, लोड नो लोड full load or divided by no load or that. Yes. Now we are doing
So these are for the electric vehicle.
Vehicle. What? Electric vehicle. What is it?
Electric vehicle. Jadi pati ki chunga up to below 60 namunga drive kunsa. Namun sera beautiful discharge. Jadi nanti kalau namunga below 50 namunga dia generator sih kan.
And below below 60 ta se kam dekala da ko battery discharge होगा ना, discharge या near to discharge. No alta se kam engine se kam de rawani kan, engine sera भी हो generator rawani.
Yes sir.
No, agar they start the engine roar, chicken the generator rawan pretty was very calm and cool, slow jet वाले rawani, slow jet भी चली. Like a गाड़ी से start के वो road पे ना चले, बस एक पक्का rawani slow jet. लग शांत पेट्रोल वर्जी, अब engine दास तावेगी आगे सर generator chicken the battery पे continuous बिजली वर्ती. પછી બે 60 ને 10 બેમ જનરેટર છે આમ જનરેટર ની બે ડબલ બીજલી વર્તી. खुद तरीके से आगे पल वोल्टेज कौन हमारा वाकला द्वान से कम दे रेक्टिफाई का रेक्टिफाई ना बाद से कम दे बिया वाला रेगुलेटर वो लगा हुआ रेगुलेटर ना बाद से कम दे बिया बैटरी चार्जर ऊपर डिजाइन करी आगे प्रोग्राम की मदद से कम दे शेयर करके ठीक शो how the batteries inside the electric vehicles are deep cycle batteries deep cycle batteries deep cycle batteries. These are the batteries discharged up to 80% up to 90% maximum discharge, maximum duty. Our batteries at home are non-deep cycle batteries. They are very good when it is discharge up to 40% or 50%. After that, it is, not working properly. So deep cycle batteries are designed to discharge very deep up till 80% or 90%. By the way, these batteries are dry batteries, lithium ion batteries. The dumb batteries, your mobile batteries are made from lithium batteries, dry batteries. Understand my point? So, deep cycle batteries or gel batteries are, another world of engineering, big and thick books, types of batteries. And still research is going on to create or to produce or to discover the batteries which is very good for electric vehicles. Electric vehicles पे सवाल आएगा मैंने बता दिया. Understand? तो electric vehicle कोई कम योगा तो कार करती है मोटर 3 phase system. Induction motor. Why induction motor? For DC motor from there, previously we just installed a DC series motor in electric vehicles. DC series, because DC series motors have a very good initial torque to run a motor or to run a load. Somewhere you just saw a elevator lift number 3. They give them a DC series motor. What's called DC series motor? Because they have a ability to put up the load from the rest. Very heavy torque. They just provide DC series motor. Understand? Mam chikam la gole odal the electric vehicle ki rickshaw ke niche converter that was also a DC series. And just that motor just put a 6 passengers in a rickshaw. 6 passengers, they just, with a very, normal acid batteries. ठीक सो हम ग्रैंड मॉडल बोले सको और ये परसेंटेज में टिकड़े हो AH में टिकड़े हो वोल्टेज में मारा नंबर टिकड़े हो 2448 100 एम्पियर का वाला वे वाला वे डिपेंड but they so that was an induction motor, 3-phase induction motor. Principle of operation of a 3-phase induction motor, and then synchronous speeds for rotating magnetic field speed. Another one is alaka walaka alaka walaka. And another one was rotor speed. Where is rotor speed? Another one is slip. Slip is the difference between rotating magnetic field speed and rotor speed. Take sure? And slip is in between 0% to 100%. At 100% slip, rotor is at rest. At 0% slip, rotor is at the speed of rotating magnetic field speed. In between these 2 points depend upon the load. When load is increasing, slip is also increasing. Take sure? Take sure? Yes. La pandu nazam sanuli gay. Or just tapos mano gay. Any questions? Any questions?
So if you starting the power connection would be so you're running the power start would be.
Depend upon the torque, initial torque I guess you have to.
But delta connection?
अब यह कुछ स्टार्ट करे पर डाल स्टार डेल्टा कन्वर्ट स्टार्टिंग द पार मुंगा डेल्टा को चाहे कल स्टार्ट सी बेच ठीक शो वन क्वेश्चन नो सर बाहर सड़े कोई सी ना कोई सर कोई भी दास में कोई क्या बता चेहरा का अमरीकी नाम का सरा वाला मोटर चेहरा एक्सप्लेन किया तब भी आपके दिमाग में नहीं बैठेगा until and unless when you study yourself go to a home hostel and just read out the book about this topic.
Sir, how different between start and
difference when we reach to that topic we will discuss. ठीक शो चार टॉपिक तो वो सीखूंगा ना तो बोला start beyond become another near to these topics like starting method of 3-phase induction motor, stopping methods of 3-phase induction motor. When we study about the starting method of 3-phase induction motor, we will study about their star delta converter. ठीक शो बस हाँ बस कसम हाँ आज़ादा बन वो लेकिन चोर था